welcome back to another video lesson. We are starting chapter 5 and talk about integers and graphing on the coordinate plane. Those are two big topics in chapter 5. The word integers is going to be the main idea of lesson 5.1 today. So you need your two white pieces of paper that I gave to you in class. Please fill out your table of contents. 53 and 54 will be the topic of integers, and I'm going to explain what an integer is, obviously, in this video. You just have to trim down the pages, as you can see that I've done, and you will need some coloring devices. If you have any crayons or colored pencils, that would be helpful as we do this lesson and talk about what different kinds of numbers there are. Okay, so this is a graphic organizer. These are going to show you what different kinds of numbers there are in the universe. So let's start with a big rectangle, and I know yours is gray. You can go ahead and color in the different sections. Does not matter what color it is. Just helps you see things a little better and how the numbers work with each other. So if I'm going to talk about all of the numbers that we know of in the universe, they are going to be called real numbers. So that's the biggest rectangle, that's blue in my example. And you have this definition below. You can fill it in as we talk about them. Real numbers are numbers that are any possible number that exists. It's called like the universe of numbers. So all numbers fit into this category. Now we're going to get more specific. Two types of real numbers are numbers that you can put in fraction form. That's what this big circle represents. Any numbers that you can put into fraction form are called rational numbers. And that stands for this purple circle that you see in your graphic organizer. So example, 1/2. 3, any whole number you can put over 1 and it is a fraction form. 2/3, decimal equivalents also fit into that category. If a number cannot be shown as a fraction, it has a special name, that way, and these numbers that can't be expressed as a fraction and is a decimal that's never ending and doesn't repeat, they are called irrational numbers. So it's not rational, it cannot be expressed as a fraction. Two special cases are pi. Pi is a decimal that never repeats and never ends, and another one is the square root of 2, where that occurs. So it's a smaller category, that's why it's a smaller circle. And now we're going to focus mainly on the rational numbers. So now we're at the green circle. That is the highlight of chapter 5. This is the category that deals with integers. And integers include positive numbers, negative numbers, and 0. So that's the different kinds of numbers that make up what we call integers. Again, all of these numbers are real, but a more specific category are ones that we can write as fractions, that's rational, and more specific, we are just going to be talking about integers, which are positive, negative, and 0. So, within integers, we have just two different smaller categories. We have the negative numbers, those are in the green section, like -3, -19. But if we wanted to just tease out the positive numbers and 0, we would be dealing with whole numbers. So that's the red circle. Whole numbers include all the positives and that 0. So you can see we're getting more specific. So whole numbers, positive and 0, are a kind of integer, which is a kind of rational number, which is a kind of real number. But if we just wanted to talk about whole numbers, we would just be dealing with 0 and positive. The smallest circle, my yellow circle, is going to be just those numbers that you use to count with. And those are the numbers you naturally start as a child, just, oh, there's one pineapple, or there's one truck. So we are going to call this last category the numbers you learned to count with, 1, 2, 3, 4, etc. Counting numbers, that makes sense, or natural numbers. I'm just going to copy that down twice, once in your graphic organizer and once along with the definition. So here you have a lot of new vocabulary words. Rational numbers are kind of all on their own. We're not really going to deal with that. Integers is the main event for chapter 5. And I wanted you to see how they're all related, even though we're just dealing with integers. I wanted you to understand what a rational number is versus irrational, and that they're all in the category of real numbers. Now we're just going to talk about integers for chapter 5 and the rest of this lesson. So you don't have this visual. I'm just going to use it to talk a little bit about what integers are. Integers, like I said, 0 and all the positives and all the negatives. And we are going to be later on talking about the number line and graphing them as well. So that's just a little taste of what's to come. The important thing to remember is that all the positive numbers are to the right of 0 and all the negative numbers are to the left of 0. That's very important. Another thing, you will see number lines that are like a thermometer, up and down, vertical we call this. The important thing to note when you're looking at this kind of number line is that the numbers are to the right of the line, and here's our 0. Our positive integers are above 0, and our negative integers are below 0. So this is just to get some background on the negative numbers, to remind you about negative numbers and where do we see them in daily life. Just a little fun thing that I put together for us. You don't have to write anything down. So temperatures below 0 is an example of negative numbers in real life. Again, you could do below freezing if you're dealing with Celsius. Another topic and category where you might see negative numbers is this idea of owing someone money. If I don't have enough to buy a present and I want to ask my mom to loan me $10, I now owe her $10, and that can be expressed as a negative number. Overspending. Christmas season might have just ended, but now we're stuck with, oh my goodness, we have to pay back all of our credit cards that we just went crazy with. So overspending on a budget, you needed to only spend $100 and you spent $200, now you owe the credit card company some money. Elevation is going to be a great topic that we're going to see a lot in this chapter when we're dealing with positive, negative numbers and 0. Also, you can see floor plans like you see over here, where there's a basement and there's an attic and there's floors in between. All of that could be represented with positive and negative numbers as well. Diving is going to be another topic that you're going to see a lot in this chapter, where you're asked to find the depth of one diver and compare it to the depth of another diver. And you also could have this idea of the stock market. If you've ever seen the news and noticed those numbers and symbols at the bottom scrolling across, some of them will be negative, like those red ones, and some of them will be positive. You also might see red arrows and green arrows as well. The last one that I have is just scores of games. It could be football, could be golf, and those just board games, and moving forward on a game board and moving backwards on a game board. All of those kinds of things can be expressed in positive, negative numbers and 0. So we're going to talk a little bit about key words that allow us to say, oh, they're talking about a positive value or a negative value or 0. One last thing, I do want to talk about that idea of 0. The integer 0 is important. It's neither positive nor negative. It's all on its own. That's why it had its own little category. And the number 0 can have different meanings based on whatever real world idea is going on, whether it's elevation or whether it's a score of a game. Sometimes 0 represents the amount that does not change. So if you didn't gain any points or lose any points, there was no change, and that is an idea of 0. Or it also could be represented as an idea like sea level, okay? And you're going to have to explain the meaning of 0 tomorrow in class, so that's why I'm taking some time to actually talk about 0 in general. And what it represents depends on the situation that you're given. Now onto your notes. These are the key words that will tell you, ooh, we're going to deal with a positive number, ooh, we're dealing with a negative number. And then we're going to talk about that meaning of 0 on the last column. So you could probably look and figure out some of these words on your own, but I'm just going to go really quick through them. If you're dealing with a gain, this often is related to football, gaining yards or a loss of yards. That is a situation where you could represent with positive and negative numbers. If the ball did not move either direction, no yards were gained or lost, that's what the 0 means, that there was neither a loss nor a gain. You could also talk about above or below normal, and if there was no above or below normal, everything is the normal amount. So that would be a case perhaps when you're dealing with rainfall. The normal amount in the month of August is, say, 20 inches, and we got 2 above the normal, so that would be 22 inches, or 2 below the normal, and so on and so forth. So another key word that will mean positive or negative is increase or decrease. And again, if it did not change, that is the 0. Neither, whatever the topic is, increased or decreased, that's what the 0 could represent in that situation. You could either earn money for the next one or spend money. And the 0 in that situation is neither earning nor spending. So you can kind of see the pattern here that's coming. Related to money is this idea of a bank account where you are depositing or putting in money or withdrawing or taking money out. So if you withdraw money, your bank account goes down. And if you didn't do anything, there was no change in your bank account, and there was neither a deposit nor a withdrawal made. On to board games. If you're literally going forward on a game board or backwards, you could show that with positive or negative numbers. Or if your game piece stayed right in the spot that it was, then no change occurred. It didn't go forward or backwards. That's the 0. This is a big one. That's why I wanted you to put the meaning of 0 here. Elevation deals with above ground, below ground. And so the 0 in this situation is sea level. That one comes up a lot. This last one also is related to a specific game of golf. Golf deals with what's idea of par. And if you are above par or below par, your points are added and subtracted accordingly. You can also deal with different kinds of games where it's a good thing to be close to 0. That's the idea of that last topic. So again, these are just some situations where you could represent things by integers, positive, negative, and 0. And we are going to have to talk about the meaning of 0 in the first 2 examples. So example 1, this is a situation where you have to actually write the integer and then explain the meaning of 0. So a gain of $2 a share, that's the idea of the stock market, shares of a company. So that a gain is an idea that, oh, we're going to deal with a positive number, positive 2. You do not have to show the positive symbol. If there is a positive symbol, obviously it's positive, but if there's nothing, you have just a positive number assumed. So if there was no gain or loss, the meaning of zero, the zero represents no gain nor a loss. So it's the idea of no change at all, nothing was gained or lost if you're talking about zero in this situation. For example 2, it says 10 degrees below zero. Below tells us we're dealing with a negative number. And again, that negative symbol is like the subtraction sign, and it will always be in front of the number, not like positive. If you have a negative number, you need to put that symbol in front of the number. In this situation, we're dealing with temperature. So the zero in this situation is specific and represents, the zero represents (0 degrees. So sometimes the zero represents no change. Sometimes it's actually talking about something specific, like a degree on a thermometer or sea level. The last part of this lesson deals with actually graphing positive, negative numbers and zero on a number line. So this is on your notes, so please fill it in along with me. Negative numbers, positive numbers, and zero, all integers, can be graphed on a number line. Like I mentioned before, there can be a horizontal or a vertical number line that we're going to use. We're going to see both. And the two important things is that you have to draw a point on the number line. I'm going to show you how to actually put the numbers on there. Sometimes there'll be numbers, sometimes there won't be numbers. And then the last thing that I wanted you to know is that you're going to see this word set. A set of numbers just means a group of numbers. And you're going to see it grouped together with these braces, those little squiggly lines. And then you'll just see the integers separated by commas. And those are the numbers you have to put on the number line. So let's try some examples and then we'll be done. Example 3, you have a vertical number line on your notes. That's where we're going to graph this set of integers. The first thing you have to do if there are no numbers is look at your numbers and that you have to graph and see what's the smallest and what's the biggest, because that's the span that you have to have numbers to the right to be able to graph. So I'm seeing -3 and +3. I have to test it out. I don't know if I can go every one number per hash mark or not. So if this was a 3, this would be a 2, and then we're dealing with negative numbers below. And we do have enough room to have every little tally a number with only one number in between. So these are all consecutive. We didn't have to skip around. Notice I wrote the numbers in line with the hash marks. Don't write them in the spaces. And the numbers are to the right. Now we're ready to plot, and we will have to draw a circle at the intersection for -3 and for 0, -2 and 3. So it's not that hard once you get it set up. You have to test out whether you can go every one, or maybe you'll have to skip by 2s, and just make sure it's lining up with the line itself and that the dot is very visible. Make sure that it's not humongous, make sure that it's not invisible either. A happy medium. The rest of our examples are all horizontal. So when you have a horizontal number line, the numbers go below. Again, we're going to line them up with these little lines here. And again, you have to look here first at the numbers and see, can you go every one, or do you have to skip by 2s or 5s? So I'm looking at my lowest number is -7 and my highest is 1. So I'm going to try and start with -7 and see if I have enough room. And notice when I'm doing negative numbers, I start on the left and I'm counting down. Okay, that's important. And then 0 is after -1, and then I start my positive numbers. This is only a section of the big number line. 0 does not have to be in the center. It happened to be in our first example, but you'll see that the 0 can be anywhere, and you can start with any number. You just want to make sure you have all of these spaces or spots represented so that you can graph them. So again, if you see the 0, the 1, 2, 3, 4, it gets bigger as we go to the left, and 1, 2, 3, 4, it gets bigger as we go to the right, number-wise. The negative numbers, though, as you get farther away from 0, they get smaller. So, just an important thing to note on how the number line is constructed. So -7, we're going to have a dot right at the intersection, just like before, and at -4, -1, and +1. So the hardest part is setting up the numbers, in my opinion, and making sure that you are specific and exact when you're putting your dots on. Example 5 set is 10, -6, -4, and 8. And if you started at -6, 5, 4, 3, 2, -1, 0, 1, 2, we won't have enough to go all the way to 10. So I'm going to skip by 2s. These are all even numbers, so I'm going to start at 10 and go 8, 6, 4, 2, 0. So my 0 ends up being here. If I go to the right, my numbers are getting bigger by 2s. Now I have to go to the left, and I'm going to have -2, -4, -6. Notice the numbers are getting bigger. Obviously, with a negative number, it's actually getting smaller as you go to the left. Now I'm ready to plot my points. I have -6 and -4, and then I'm going to come over here and do an 8 and a 10. So all of my examples up until this point have been literally, you put the dot on where the line crosses the hash mark and this blue line. It's not hovering up here. It's literally sitting on the line. Make sure your dots are sitting on the line. Our final example deals with 8, -7, 0, and 3. -7 is my smallest. If I go -7, -6, -5, -4, -3, -2, -1, 0, 1. I don't have enough room. So I'm going to have to go by 2s. That's my next biggest. And if I go with 8, that's the highest, I can go down by 2s. And my 0's in the center, happens to be. And then I'm going to do the same, counting 2, 4, 6, 8, but we have our negatives on the left. Now for this one, 8 is easy because it's sitting on this intersection. -7 though, you have to go in between -6 and -8. So on a number line, there could be situations where you have to put a dot, not on an intersection where this little hash mark meets the line. -7 exists halfway between 6 and 8. 0's easy, but you'll notice the last number, 3, we also have to do that same thing. So between 2 and 4 is where +3 is. Be careful when you're doing this. This is a little bit trickier if you're not paying close attention to the fact that the numbers are going 2, 4, 6, 8. You have to go beyond -6 to graph -7. We will be graphing and talking about the meaning of 0 and representing real life situations with integers tomorrow. I hope you have a good night.